Alright, so good evening everyone and welcome to another episode of Moyo Math. Today we're going to be looking at a very important topic, matrices. You know, you see matrices in the Csec exam almost every year, and we want to ensure that our understanding of matrices is clear. So we're going to be doing some practice questions today involving the following topics: addition and subtraction of matrices. You see questions where that is involved. Similarly with multiplication of matrices, solving equations in matrix form, finding the determinant of a matrix, singular and non-singular matrices, the inverse of a matrix, the identity matrix, and solving simultaneously a pair of linear equations using the matrix method. So we'll be looking at questions on the Csec past papers where you have the following topics involved. So let's get straight into it. So looking at the first question, L has a matrix. So we have L, this matrix, 3, 2, 1, 4, and M has a matrix, negative 1, 3, 0, 2. And they want us to evaluate 1, L plus 2M. Alright, so looking at matrices. So, L plus 2M. So 2M, of course, will involve multiplication of matrices called scalar multiplication. We're going to add that result to matrix L. So what I'm going to do is to work out 2M first. So 2M will be 2 times the matrix M, whose elements are negative 1, 3, 0, 2. And let me multiply 2 by each one of those elements within. So 2 by negative 1 is negative 2, 2 by 3 is 6, 2 by 0 is 0, 2 by 2 is 4. So this is what 2M is equal to. So let us add 2M to L. So this is L plus 2M. So the matrix L, set it up in the order in which it's stated. L is 3, 2, 1, 4 plus 2M. The elements are negative 2, 6, 0, 4. And let's add. So you add matrices. You add matrices once they have the same order. This is a 2 by 2 matrix. We have 2 rows running horizontally, 2 columns running vertically. Same 2 rows running horizontally, 2 columns running vertically. So what we're going to do is to add them by taking first element 3 plus first element negative 2, second element plus second, third plus third, and fourth plus fourth. That will simplify to a plus by a minus is a minus. So 3 minus 2 is 1. 2 plus 6 will be 8. 1 plus 0 will be 1. 4 plus 4 is 8. So the answer here is 1818. That's L plus 2M. So let's look at LM. So that's part 1. So part 2, we're looking at Lm. This is L multiplied by M. So we see Lm in that order. L first, 3, 2, 1, 4 multiplied by the matrix M, negative 1, 3, 0, 2. Now when we multiply two matrices, they do not have to be on the same order, but they must be compatible. Meaning, what's the order of my matrix L? 2 rows running horizontally, 2 columns running vertically, 2 by 2 matrix. Matrix M, 2 rows running horizontally, 2 columns running vertically, 2 by 2 matrix. But they are compatible when the 2 inner numbers are the same. Once they are the same, it means we can multiply them by looking at the order. And 2 outer numbers will tell us what's the order of the end result. When you multiply those 2 matrices, you must get a 2 by 2 matrix. So how do we multiply matrices? We take the rows of the first matrix and we're going to multiply by the columns of the second matrix. So I'm going to say here row by column. First row by my first column. So I'm multiplying 3 by negative 1 plus 2 by 0. So this is my first row by my first column dealt with here. Now my second row by my first column. So I'm going top bottom. So 1 is linked to negative 1. So 1 by negative 1 plus 4 is linked to 0. 4 by 0. So that's my first 2 rows of my first column dealt with. Now let's take my 2 rows with my second column. So first row, second column. So 3 is linked to 3, so 3 by 3 plus 2 is linked to 2, 2 by 2. So that's first row, second column. Now I'm taking my second row, second column. 1 is linked to 3, so that's 1 by 3 plus 4 is linked to 2, so that's 4 by 2. So when we simplify that, we're going to get what? 3 by negative 1 is negative 3 plus 0 by 2 is 0. 3 by 3 is 9 plus 2 by 2 is 4. 1 by negative 1 is negative 1 plus 4 by 0 is 0. 1 by 3 is 3 plus 4 by 2 is 8. So when we simplify that, what we're going to get as our final answer. This will be equal to negative 3 plus 0 is negative 3. 9 plus 4 will give us 13. Negative 1 plus 0 is negative 1. And 8 plus 3 is 11. So that will be our result for LM. So let's look at question 2. So question 2, I'm using. L and N are two matrices. So we have L, whose elements are 3, 2, 1, 4. And we have the matrix N, whose elements are negative 1, 3, 0, 2. And what they want us to find is L subtract N squared. So we see where multiplication will come into play here. N squared, it's N by N. When we get that result, we're going to subtract that result from the matrix L. So let's work out N squared first. So N squared, it's not squaring each one of these inside here. Students like to make that mistake. It's not 1904. Don't make that mistake. N squared is matrix N by itself. That is N squared. So I'm going to state matrix N, negative 1, 3, 0, 2, times matrix N, negative 1, 3, 0, 2. These two matrices are compatible. I can't multiply them. This is 2 by 2, 2 by 2. The two inner numbers are the same. The outer numbers will tell me the end result is a 2 by 2 matrix. Let me multiply rows of the first by columns of the second. I'm multiplying first row, first column. Negative 1 by negative 1 plus 3 is linked to 0, 3 by 0. Second row, first column, 0 by negative 1 plus 2 by 0. So that's my first two rows of my first column dealt with. First two rows of my second column, first row, second column. Negative 1 by 3, negative 1 is linked to 3, negative 1 by 3 plus 3 is linked to 2, 3 by 2. So let's take now my second row by my second column. 0 is linked to 3, 0 by 3 plus 2 is linked to 2, so that's 2 by 2. When I simplify that, let's see what we're going to get L squared to be equal to. Negative 1 by negative 1 is 1 plus 0 by 3 is 0. Negative 1 by 3 is negative 3 plus 3 by 2 is 6. 0 by negative 1 is 0 plus 0 by 2 is 0. 0 by 3 is 0 plus 2 by 2 is 4. So we're going to get L squared to be equal to what? This is 1, 3, 0, and 4. So that's the result for N squared, right? So what we're going to do now is to subtract N squared from L. So again, to set it up, right to the corner here, this is L now. Subtract N squared. So I'm going to write L, 3, 2, 1, 4, matrix set up in that order. Subtract N squared, whose result is 1, 3, 0, 4. Let's subtract. Of course, both are the same order, so we can subtract them. So we're going to say first element, subtract first element, second, subtract second, third, subtract third, and fourth, subtract fourth. And when we simplify, what we're going to get for L subtract N squared, 2, negative 1, 1, 0. That's the result. Yeah, so pretty straightforward. Don't forget everyone to like, share, and subscribe to Moyo. So very straightforward questions we see in the Csec exam paper. So let's look at another. So looking at question 3. So we want to ensure that our foundation for matrices is very solid. You know that this is a topic you'll see in the Csec exam almost every year. So let's make sure we understand it well. So this one, explain why the matrix product QS is not possible. So QS is Q multiplied by S. Let me write down what is matrix Q first. Matrix Q, the elements are 2, negative 1, 4, 3. Matrix R, the elements are 1, 6, negative 5, 4. And matrix S, the elements are 2, 7, 4, negative 1, negative 8, 9. So explain why the product QS is not possible. So QS, that's Q multiplied by S. So let me set it up in the order. Q first, 2, negative 1, 4, 3 times S, 2, 7, 4, negative 1, negative 8, 9. Remember, when we're multiplying two matrices, we must ensure that they're compatible, right? How do you know when two matrices are compatible? Check the orders. The order of this matrix will be 2 rows running horizontally, 2 columns running vertically, 2 by 2. The order of this matrix will be 3 rows running horizontally, 1, 2, 3. And how many columns running vertically? 1, 2. So clearly the two inner numbers are not the same. So they are not compatible. So this tells us really, this is rows, this is columns, this is rows, and this is columns. What this is telling us is the number of columns of the first matrix is not equal to the number of rows of the second matrix. So that is what that is telling us. So therefore, we cannot multiply those two matrices. It's not possible. Let's say that part 2. This is part 1, part 2. So you want us to now state the matrix product SR. So that's matrix S multiplied by R. So let's set it up. S, whose elements are 2, 7, 4, negative 1, negative 8, 9 times R, 1, 6, negative 5, 4. Right? So, can we multiply those two matrices? You have to check that first. Always remember to check that first, right? The order of this matrix will be 1, 2, 3 rows, 2 columns, 3 by 2. The order of this matrix will be 2 rows running horizontally, 2 columns running vertically, 2 by 2. And if you look, the two inner numbers are the same, which means we can multiply them, and the outer numbers will tell us that the end result is a 3 by 2 matrix. So the end result will look like this one here. So how we multiply? We're going to say here what? Rows of the first, so 3 rows, by the columns of the second. So let me multiply. First row by my first column. That is what? First row by first column. 2 by 1 plus 7 is linked to negative 5. 7 by negative 5. Then second row by my first column. So I'm going below that. 1 is linked to 4. 4 by 1 plus negative 1 by negative 5. Then my third row by my first column, negative 8 is linked to 1. Negative 8 by 1 plus 9 by negative 5. Right, so that's my first 3 rows with my first column. My 3 rows with my first column. Now let's take my 3 rows with my second column. So this is what? 2 by negative 6 plus 7 by 4. And this will be second row by my second column, 4 by 6 plus negative 1 by 4. Then I'm going to multiply my third row by my second column, negative 8 by 6 plus 9 by 4. When we simplify that, what are we going to get? This is 2y1 is 2 plus negative 5 by negative 7 by negative 5 is negative 35. Then we're going to have 2 by 6 is 12 plus 7 by 4 is 28. We're going to have 4 by 1 is 4 plus negative 1 by negative 5 is 5. 6 by 4 is 24 plus negative 1 by 4 is negative 4. I'll put negative 4 in brackets to separate two signs. Negative 8 by 1 is negative 8 plus 9 by negative 5 is negative 45. So that's negative 45, so I'll put negative 45 in brackets to separate two signs. Negative 8 by 6 will be negative 48 plus 9 by 4 is 36. So we simplify that. What we're going to get as the final answer. This will be what? Plus by a minus is a minus. So 2 minus 35 is negative 33. 12 plus 28, that will give us 40. 4 plus 5 is 9. Plus by a minus is a minus. 24 subtract 4 is 20. Plus by a minus is a minus. Negative 8 subtract 45 will give us negative 53. And negative 48 plus 36 will give us negative 12. So that is the end result when we multiply S by R. The end result here is a 3 by 2. 3 rows, one in horizontally, 2 columns, one in vertical. Alright, so let's move on to the next. So we're going to have question 4. Right, so question 4. Oh, so they want us to calculate this is part 3 of this question. So part 3 of this question, they want us to calculate the matrix product QR. So let's go back to QR. Q's elements are 2, negative 1, 4, 3. R's elements are 1, 6, negative 5, 4. So let's multiply. Part 2 didn't want us to multiply it. Part 2 just asked us to state the order of the matrix product SR. So let me just do that part there. Let's do part 2. Part 2, so now reading part 2, it says here, carefully state the order. This is why it's important to read the questions carefully. The order of the matrix product SR. So SR, S is 2, 7, 4, negative 1, negative 8, 9. But if we have to multiply, that's the result we're going to get. And R, it is 1, 6, negative 5, 4. So we know this will be 1, 2, 3 rows, 2 columns. So rows run horizontally, 2 columns running vertically. This will be 2 rows by 2 columns, 2 by 2 matrix. The 2 inner numbers are the same, so we can multiply them. The outer numbers will tell us the end result is a 3 by 2 matrix. So that will be the answer for part 2. Okay? Part 3, so if we have to multiply, then you'll get some practice multiplying 3 by 2 by 2 by 2 matrix. Then, so let's look at part 3. Part 3, they want us to now calculate the matrix product QR. So I'll erase here. So part 3, QR. So matrix Q, the elements are 2, negative 1, 4, 3. R, the elements are 1, 6, negative 5, 4. And they want us to calculate the matrix product QR. So when you multiply, always check the orders. 2 by 2 matrix, 2 rows, 2 columns, also a 2 by 2 matrix. The 2 inner numbers are the same. so they are compatible. The outer numbers will tell us the end result is also 2 by 2. So how do we multiply? We take the rows of the first by the columns of the second, and that's what we're going to get. This will be first 2 rows by my first column, first row, first column. 2 is linked to 1, so 2 by 1 plus negative 1 is linked to negative 5, so negative 1 by negative 5. That's first row, first column dealt with. Now let's multiply our second row by our first column, so top, bottom. 4 is linked to 1, so 4 by 1 plus 3 is linked to negative 5, so 3 by negative 5. Then my 2 rows by my second column, so first row, second column. 2 by 6 plus negative 1 by 4. Then my second row by my second column, 4 by 6 plus 3 by 4. When we simplify that, what are we going to get? 2 by 1 is 2 plus negative 1 by negative 5 is positive 5. 2 by 6 is 12 plus negative 1 by 4 is negative 4. We put that in brackets. 4 by 1 is 4 plus 3 by negative 5 is negative 15. Then we're going to have 6 by 4 is 24 plus 3 by 4 is 12. When we simplify that, we're going to get 7 plus by and minus is a minus, so 12 minus 4 is 8 plus by and minus is a minus, 7 minus 15, 4 minus 15, sorry, is negative 11, and 24 plus 12 will give us 36. So that is our result in the matrix product Q1. Alright, let's move on to question 4. Right, so don't forget to ensure that you like, share, and subscribe to Moyo. So, given matrix A, it's a very important question. Matrix A has elements 4, negative 1, negative 7x. And they ask you now, very, I'd like to bring this question in the matrices, questions. Normally it's a common part in the matrices question. Determine the value of x when, and when students see those two parallel lines on either side of the matrix, this here means the determinant of matrix A. The determinant, and you know what's the determinant of a matrix? For a matrix A, B, C, D, the determinant is to multiply A by B, subtract B by C. That's the determinant of the matrix. And it's only applicable to a 2 by 2 matrix. So the determinant of this matrix A, right in my formula, is AB minus BC, and that's equal to 5. Keeping in mind A is 4, B is negative 1, C is negative 7, and D is x. And if you ask us to find x, it means in math you have to create an equation, which we have here. That's our equation. Let's substitute. A is 4 in brackets, D is x in brackets, subtract B is negative 1 in brackets, C is negative 7 in brackets is equal to 5. Simple equation, let's solve it. So 4 by x will be 4x, subtract negative 1 by negative 7 is positive 7 is equal to 5. And let's solve for x. So I'm going to add 7 to both sides. 4x is equal to 5 plus 7. 4x is equal to 12, and therefore I can divide both sides by 4. X is equal to 3. So that's my value of x. So now when I see those two parallel lines on a matrices question, it means determinant. What's the determinant? AB minus BC, only applicable to a 2 by 2 matrix. Alright? Okay, let's look at part B. Part B, matrices L and M are defined as follows. So you have L, whose elements are 9, 5, 3, 2. M, whose elements are 2, negative 4. Evaluate each of the following. 1. The matrix product L, M. So we multiplying those two matrices, L multiplied by M. So we set it up. You go ahead with it stated, 9, 5, 3, 2 times M, 2, negative 4. And remember when you're multiplying two matrices, always check to make sure they are compatible. Alright, so what's the order of this matrix? 2 rows running horizontally, 2 columns running vertically, 2 by 2. What's the order of this matrix? 2 rows running horizontally, 1 column running vertically, 2 by 1 matrix. The two inner numbers are the same. So it means we can multiply them, and the outer numbers will tell us the end result is a 2 by 1 matrix. So the end result will look like this one here. How we multiply two matrices? We take the rows of the first by the only column, and let's multiply. First row by my only column. So it's 9 by 2 plus 5 by negative 4. First row, first column dealt with. Now, second row, first column, 3 by 2 plus 2 by negative 4. And therefore, when we simplify, we will get 9 by 2 is 18 plus 5 by negative 4 is negative 20, which I put in brackets to separate the two signs. 3 by 2 is 6 plus 2 by negative 4 is negative 8, which I put in brackets to separate the two signs. When I simplify, I'm going to get here a plus by a minus is a minus, 18 subtract 20 will give me negative 2. A plus by a minus is a minus, 6 minus 8 is negative 2. That's the result when we multiply L by M. So that's that part 2. Or question 5, sorry. This was question 4, moving on to question 5. Right, so we have this matrix M is defined by, this matrix M, this is A, defined by 2p, negative 3, 4, and 1. And another, again, very important question. Determine the value of P for which the matrix M is singular. So keyword singular. So what we know for a singular matrix? Very important to remember. For a singular matrix, the determinant AB minus BC is always equal to 0. Right? And in this question, I want you to find some unknown. And when you have to find an unknown in math, what you do? Create an equation. This is the equation here, right? Yeah? So this is A, B, C, D. And let's substitute for A. A is 2P in brackets times D is 1 in brackets. Subtract B is negative 3 in brackets. C is 4 in brackets is equal to 0. So this will be what? 2P by 1 is 2P. Subtract negative 3 by 4 is negative 12. And I'll put negative 12 in brackets to separate the two signs. Is equal to 0. This will be 2P. A minus by A minus is A plus 12 is equal to 0. Let's solve for P. So I will just subtract 12 from both sides. I get rid of the 12 first. So I subtracted 12 from both sides. So this will be 2p is equal to negative 12. We can take the positive 12, bring it over, change the sign. And then to get p by itself, I'm going to divide both sides by 2. When the two 2's divide into each other, p is equal to negative 12 by 2 is negative 6. That's the result for P. Let's look at part B. Right, so part B, again you have these two matrices. A and B are two by 2 matrices. A, 1, 2, negative 4, 3. B, 5, negative 1, 0, 3. And what I want us to calculate? 1. 2a plus b. I would not confuse us. We would have straightforward, simple, easy thing. So we're going to do what? Work out 2a first, That's scalar multiplication. 2 in front is known as a scalar, right? We call it a scalar. So you're multiplying 2 by matrix A. So 2 by matrix A will give us what? 2 by 1 is 2, 2 2s are 4, 2 by negative 4 is negative 8, 2 by 3 is 6. That's 2A. So let's now add 2A, matrix 2A to B. And 2A, set it up in the order in which it is stated, 2, 4, negative 8, 6, plus B, 5, negative 1, 0, 3. And we can add these two matrices because they are the same order. We can only add or subtract matrices provided the orders are the same, right? And what are we going to do? First plus first, first element plus first element, second plus second, put negative 1 in brackets to separate the signs. Third plus third, negative 8 plus 0, fourth plus fourth. When we simplify that, what are we going to get? 7 plus by a minus is a minus, 4 minus 1 is 3, negative 8 plus 0 is negative 8, 6 plus 3 is 9. That is the result for part B, 2A plus B. Right, let's move on to question 6. Determine the values of the unknown in each of the matrix equations. So the matrix equations, you have to know to solve for unknown quantities when given a matrix equation, right? So you have 1. So you have this matrix equation 4, 0, negative 2, 5 plus x2, 8, negative 1 is equal to negative 3, 2, y4. So that is a matrix equation, and what you want to solve for is the unknown values, which are x and y. Good? So we're going to solve. We add these two matrices, right? So let's add them without add matrices. They both have the same order, so you can add them. This is 4 plus x, first plus first, 0 plus 2, second plus second, negative 2 plus 8, third plus third, 5 plus, I'll put your negative 1 in brackets to separate the signs, 4 plus 4. That will be equal to negative 3, 2, y4. Let's simplify further. What we can simplify, we can't add 4 to x. Don't write this as 4x. These two terms are not like terms, you can't add them. So this stay as is, 4 plus x. 0 plus 2 is 2, negative 2 plus 8 is 6, plus by and minus is a minus, 5 minus 1 is 4. This is equal to negative 3, 2, y4. Now, to solve for the unknowns, all we're going to do is to equate. All we're going to do is simple equate it. First element is equal to first element. So that's one equation, because if you have to solve for an unknown, you have to create an equation, right? So that's the equation here 1. And we can say third is equal to 2. So 6 is equal to y. So we're already found y is 6. And then x, simple, solving that equation. So from 1, 4 plus x is equal to negative 3. And we're subtracting 4 from both sides. Negative 3 subtract 4. And therefore x is negative 7. So I found x, and I know y is equal to 6. Yes, x is 7 and y is 6 previously. So let's look at part 2. So these are what are called matrix equations. Don't forget that you want to like, share, and subscribe to Moyo. Alright? Let's look at the next. So we have here part 2. Another matrix equation. We have 5, negative 3, 2, 3 times, I know you're multiplying, right? This is A, 2, C, negative 1 is equal to negative 10, 13, 17, 1. Alright? So again, we multiply, let's multiply these two matrices and then we do some equating, that's all, and we're going to solve. So this will be, these two are compatible, 2 by 2, 2 by 2, two inner numbers are the same, outer numbers tell us the end result is a 2 by 2 matrix. So let's multiply. So we're taking the rows of the first by the columns of the second. So I'm going to multiply. 5 is linked to A, so 5 by A plus negative 3 is linked to C, so negative 3 by C. First row, first column. Now second row, first column, top, bottom. So 2 is linked to A, 2 by A, plus 3 is linked to C, so 3 by C. Then my 2 rows by my second column, first row, second column, 5 by 2, plus negative 3 by negative 1. Now second row by my second column, 2 by 2, plus 3 by negative 1. So we simplify that, what we're going to get. And of course that will be equal to negative 10, 13, 17, 1. Okay? So let's simplify. What we're going to get? 5 by A is 5A plus negative 3 by C is negative 3C, put that in brackets. 5 by 2 is 10 plus negative 3 by negative 1 is positive 3. 2 by A will be 2A plus 3 by C will be 3C. Then 2 by 2 is 4 plus 3 by negative 1 is negative 3, which I place in brackets. Of course, that will be equal to negative 10, 13, 17, 1. So, let's further simplify. If not, let's do some equating one time. Okay, well let me simplify further. It says A plus by a minus is A minus, 5A subtract 3C, 10 plus 3 is 13, 2A plus 3C, remember, these two of course will stay as is because they're not like terms, you can't add them or subtract them, right? A plus by a minus is a minus, 4 subtract 3 is 1. That is equal to negative 10, 13, 17, 1. So let's do some equating. So we can find A and C. So I'm going to say 5A minus 3C is my first element in that matrix is equal to the first element in the second. This is my third element in the first matrix. And that is equal to the third element in the second matrix. Right? So we have our two equations here. And the only way we can solve those two equations because they have both have the same unknown quantities, both have A and C. The only way we can solve for A and C is to solve those two equations simultaneously. So let's solve it simultaneously. So this will be solving simultaneously. So testing knowledge of solving a pair of equations simultaneously. And that will give us, this will give us 5A minus 3C is equal to negative 10. And we have 2A plus 3C is equal to 17. So let's solve simultaneously. What I can easily do is to eliminate C because 1, the numbers in front of C are the same, but when we have different signs in front of our two numbers that are the same, once we have different signs in front of the two numbers that are the same, of course we are eliminating C. So what we're going to do here is because these two signs in front of our two numbers that are the same are different, we're going to add add the two equations in order for us to eliminate. So I'm going to add, and let me add 5a plus 2a negative 3c plus 3c is 0, and this will be negative 10 plus 17. So 5a plus 2a is 7a, negative 10 plus 17 is 7, and therefore to get a by itself, I'm going to divide 7 on both sides, and therefore a is equal to 1. And after I've found a, what I want to do is to find b. So how am I going to find b? I'm going to substitute a equal to 1 into any of the original equations. This is equation 1, equation 2. So I'm going to substitute a equal to 1 into equation 2. Equation 2, we have 2a plus 3c is equal to 17. I'm going to replace a with 1, 2 times 1 in brackets, plus 3c is equal to 17. 2 by 1 is 2, plus 3c is equal to 17. I'm going to subtract 2 from both sides. 3c is equal to 17, subtract 2. 3c is equal to 15, and therefore I'm going to divide both sides by 3. 3c over 3, 15 over 3, c is 5. So therefore we have found a and we have found c. So a is equal to 1 and c is equal to 5. Alright, so that is solving our two matrix equations given in that question. Alright, so let's look at the next question. So getting some question practice, look at any type of questions you can see in a Csec exam matrices, and you want to be familiar with most of these questions tell you, right? So, matrices A and B are such that A has elements 3, 2, 5, 4, and B has elements 4, 0, 3, negative 1. And what does it show? And this is what you call a commutative law. So what does it show for multiplication? AB is not equal to BA. Right? So the commutative law is not applicable here. Remember what's the commutative law? Commutative is 2 by 3. If you switch them around, it's the same as 3 by 2. But for matrices, the commutative law does not apply when they multiply matrices. And let's prove that. Let's prove it. Let's prove when we multiply A by B is not equal to B by A. Good? Straightforward. You know A by B is what? 3, 2, 5, 4. B is 4, 0, 3, negative 1. So let's multiply. Remember they are compatible. Rows by columns. Both are 2 by 2 matrices, so they are compatible. First row, first column, 3 by 4 plus 2 by 3. First row, first column dealt with. Second row, first column, top, bottom, 5 by 4 plus 4 by 3. Then I'm going to take my 2 rows with my second column. First row, second column, 3 by 0 plus 2 by negative 1. Then my second row by my second column, 5 by 0 plus 4 by negative 1. Let's look at what is AB. You're going to get here 12 plus 6, 0 plus negative 2, 20 plus 12, 0 plus negative 4. Of course, negative 2, negative 4 in brackets, okay? This will give us 18 plus by a minus is a minus, 0 minus 2 is negative 2, 20 plus 12 is 32, a plus by a minus is a minus, 0 minus 4 is negative 4. So this is what AB is equal to, the result of AB. So let's work out what let's see what that is equal to now. So we switch in the order, B first, A after, 4, 0, 3, negative 1 times A, 3, 2, 5, 4. And again, let's multiply. They are compatible. So we take the rows of the first by the columns of the second. So 4 by 3 plus 0 by 5. First row, first column dealt with. Second row, first column, 3 by 3 plus negative 1 by 5. That's my second row, first column. Now, 2 rows of my second column. First row, second column. 4 by 2 plus 0 by 4. Now, second row, second column. 3 by 2 plus negative 1 by 4. When we simplify that, what are we going to get? 4 by 3 is 12. 5 by 0 is 5. 4 by 2 is 8. 4 by 0 is 0. 3 is 9. Plus negative 1 by 5 is negative 5. 3 by 2 is 6. Negative 1 by 4 is negative 4. Of course, place in brackets. When we simplify, we're going to get 12. 8 plus by a minus is a minus. 9 minus 5 is 4. Plus by a minus is a minus. 6 minus 4 is 2. So clearly what we see here, AB is not equal to B. Alright? So hence shown. Make sure right hence shown anytime you ask you to show something in mathematics, alright? Right at the end, hence shown. Alright, now let's find very common what you see in a matrix question. Find the inverse A to the power of negative 1. What's the inverse of matrix A? So let's look at that. So we can have part 2. This was part 1. So part 2. So we have here. So part 2, they want us to find A to the power of negative 1, which represents the inverse of the matrix A. So to find the inverse, you have to know what's the formula for the inverse. It's always 1 all over your determinant. Remember the determinant is, let me write it back here, we have a matrix A, B, C, D. The determinant is A multiplied by D minus B multiplied by C. That's the determinant. You have to also know what's the adjoint of a 2 by 2 matrix. The adjoint is to interchange A and D. So D will be placed here, A will be placed there, but to change the signs of B and C. So positive B becomes negative B, positive C becomes negative C. That's the adjoint. They are both determinant and the adjoint, and both are going to be applicable to the inverse of your matrix. So this will be part 2. A inverse is 1 all over your determinant AB minus BC times your adjoint D negative B negative C. That's your formula, alright, for the inverse. Now they want us to find the inverse of this matrix A. Matrix A, you know, is 3, 2, 5, 4. And let's substitute all that we need to substitute into that formula. Keeping in mind this is A, B, C and D, right? So let's substitute. A inverse will be 1 all over A, which is 3, times D, which is 4, subtract B, which is 2, of course, all in brackets, times C, which is 5 in brackets. Multiplied by the adjoint, interchanging both A and D. So I'm going to place 4 here, 3 here, I'll interchange them first, and I'm going to change the signs of B and C. Positive 2 becomes negative 2, positive 5 becomes negative 5. When we simplify this, we're going to get A inverse will be 1 all over 4 by 3 is 12, subtract 2 by 5 is 10, times the adjoint 4 negative 2 negative 5, 3. And that will simplify to A to the power of negative 1 is 1 over 2, which is a half, times 4 negative 2 negative 5, 3. And what you can do is multiply a half, now which is called a scalar, by each of the elements within. So this will be a half by 4 is 2, a half by negative 2 is negative 1, a half by negative 5 is negative 5 over 2, and a half by 3 is 3 over 2. So that's A inverse. So we should know to find the inverse of your matrix. Let's look at the next part of this question. So part 3, write down the 2 by 2 matrix representing the matrix product A by A inverse. So that's what us to write down the 2 by 2 matrix representing that. So the 2 by 2 matrix. So part 3. So the 2 by 2 matrix representing A by A inverse. Just keep in mind, A by its inverse, any matrix times its inverse, it doesn't matter the order, is always equal to the identity matrix. Don't forget that. And the identity matrix, it is 1, 0, 0, 1. If you multiply a matrix by its inverse, this is what you're going to get. So anytime you multiply those two matrices, any matrix by its inverse, this is the matrix you're going to get. Just one mark, just want you to state what is the result. But what you want to do too, I want to actually multiply them so you can see when you multiply a matrix by its inverse, you're going to get that. And this is all you have to write for your answer. But let's just prove by multiplying them now that you're going to get this. You can see, because sometimes I make the question to multiply them to get that. So let's make sure we can multiply to get that as the result. So A times A inverse. Let's see if we're going to get 1, 0, 0, 1. A, the matrix was, A was 3, 2, 5, 4. A inverse is what we just got here. 2, negative 1, negative 5 over 2, 3 over 2. If you have fractions, don't let the fractions confuse you. So let's multiply to see if we're going to get 1, 0, 0, 1. So this is rows, you know they are compatible, we can multiply them, both 2 by 2s. So we're taking the rows of the first, by the columns of the second. So we're going to get here what? First row, first column, 3 is linked to 2, 3 by 2, plus 2 is linked to negative 5 over 2, 2 by negative 5 over 2, that's first row, first column dealt with. Now second row, first column, this is 5 is linked to 2, 5 by 2, plus 4 by negative 5 all over 2. Then my 2 rows by my second column. First row, second column. 3 by negative 1 plus 2 by 3 over 2. So that's my first row, second column. Now my second row, second column, 5 is linked to negative 1 plus 4 by 3 over 2. So if we multiply them, we get to the same 1, 0, 0, 1. So this is 3 by 2, 6 plus 2 by negative 5 over 2 will give me negative 5, which I'll put in brackets. 3 by negative 1 is negative 3 plus 2 by 3 over 2 is 3. 5 by 2 is 10 plus 4 by negative 5 over 2 is negative 10, which I'll put in brackets. 5 by negative 1 is negative 5 plus 4 by 3 over 2 is 6. And when we simplify, we're going to get what? Plus by minus is a minus. 6 minus 5 is 1, 0, 0, 1. Yeah, and so we got that. So make sure you know when you multiply a matrix by its inverse, that is what you're going to get, the identity. And it doesn't matter the order of the matrix and its inverse. When you multiply them, you're going to get the identity matrix. Alright? Okay, so that's right. So we're going to have a question here. This is the last question here. And yes, to remind everyone, like, share, and subscribe to Moyo. Share with your friends, share with everyone you know. so last question, given D has elements 1, 9, P4 is a singular matrix, determine the value of P. So this matrix D, whose elements are 1, 9, P and 4, is a singular matrix. So if it's a singular matrix, what do we know? We know that the determinant is equal to 0. And what is to find values of P, right? Values. So this is A, B, C, D. We're going to substitute. A is 1, D is 4, pause both in brackets, subtract B is 9, P in brackets, C is P in brackets is equal to 0. So we're going to multiply 1 by 4 is 4, subtract 9P by P is 9P squared is equal to 0. Now, this equation is a quadratic equation that will bring matrices question, especially with these singular or even with non-singular matrices, where you can create an equation that's quadratic. A quadratic equation is where you have variable squared and equal sign. Variable squared makes it quadratic, equal sign makes it a quadratic equation, and the expression, the quadratic expression must be made equal to 0. Hence, we make a quadratic equation. And to solve this, we can use factorization, you know. This here, to factorize this expression, is the difference of two perfect squares. Or you can take the 4 and bring it over and then make P the subject if you want. You can do that too. So this is what? I'm factorizing 2 by 2. And this is 3P by 3P. So when you factorize, make sure you know methods of factorization. Because 4 leads, the factors of 4 will be written first. And because 9P squared comes after, the factors of 9P squared will be written after. And you're going to separate with plus and minus equal to 0. And we're going to simply say either 2 plus 3P is equal to 0, 3P is equal to negative 2, and then I divide both sides by 3, P is equal to negative 2/3. One value of P, or 2 minus 3P is equal to 0, negative 3P is equal to negative 2, subtract 2 from both sides, and then I'm going to divide both sides by negative 3, P is 2/3. So those are my two values of P. Yeah? So you can factorize and solve it. Or you can do this way, or you show this way, or you can say 4 minus 9P squared is equal to 0. You're going to do this way. Subtract 4 from both sides, 9P squared is equal to negative 4. Divide both sides by negative 9. So 2 negative 9s divide into each other. You're going to get P squared is equal to positive 4 over 9. But then to get P by itself, you have to find the square root of P squared, the square root of 4 over 9. But because it is quadratic, meaning you're getting two values of the unknown, in this case P, you must put a plus or minus sign in front of the square root symbol. So the square root of P squared makes it P, and the square root of 4 over 9 is plus or minus 2/3. The square root of 4 over the square root of 9, 2 over 3. So we have positive and negative values. Positive 2/3, negative 2/3. That's the other way you can solve that quadratic equation to get your two values of P. Alright, let's look at the part B. So this was part A. Looking at part B. Part B. Right, so given a pair of linear equations, so we have a pair of linear equations, they are 2x plus 5y is equal to 6 and 3x plus 4y is equal to 8. So we have a pair of linear equations, and what I want us to do is, if we go through the question, the last part, solve for x and y. So what we have here is a pair of linear equations which we have to solve simultaneously, but using a matrix method. The matrix method approach, not elimination or substitution, right? The matrix method. So when they ask us in part 1, let's look at part 1. Write the equations in the form AX equal to B, where AX and B are matrices. Simple. I'm just taking the numbers in front of X and Y, the coefficients of X and Y, and I'm going to put them in one matrix. 2, 5, 3, and 4. Positive 2, positive 3, positive 5, positive 4 will go in one matrix. Multiplied by XY, the unknowns in another, is equal to 6, 8, the constants in one matrix. That's part 1 there. Part 2. Show that A inverse, part 2A, sorry. Calculate the determinant of matrix A. Let's find the determinant of matrix A. So remember, this is A, this is X, that is equal to B, right? And let's calculate the determinant of matrix A, part 2. So the determinant of matrix A, remember the determinant is two parallel lines being determined in matrices. That is AB minus BC. This is A, B, C, and D. And let's substitute. A, it is 2 times D4 in brackets, of course, both in brackets. Subtract B, which is 5, times C, which is 3 in brackets. You're going to get 8 minus 15, so you're going to get negative 7 is the determinant of matrix A. Then part B asks us to show that the inverse of the matrix A is what we have there, show. So part B, we require to show, so we know that A inverse is 1 all over in your formula, the determinant AB minus BC multiplied by the adjoint. What's the adjoint? Interchanging both D and A, and we change the signs of B and C. That's your formula for the inverse. So this will be 1 all over the determinant, which is negative 7, times the adjoint, which is to interchange both A and D, for 2, and we change the signs of B and C, negative 5, negative 3. And let's multiply. This will become 1 over negative 7 is scalar by 4 is negative 4 over 7. 1 over negative 7 by negative 5 will be negative 5 over negative 7, which is positive 5 over 7. 1 over negative 7 by negative 3 is negative 3 over negative 7, which is positive 3 over 7. 1 over negative 7 by 2 is negative 2 over 7. So what we have done, hence shown. So we have shown that the inverse of the matrix is equal to what they have there. And use the inverse to solve for x and y. So let's use the inverse, which is this here, to solve for x and y. And how do we do such? So I'm going to erase this part here. So we can have part C. Part C will take us back to the matrix equation. So in order for us to get x and y is represented by x. X here represents the unknowns. And in math, anytime you have to get the unknown quantity by itself, in this case I need to get x by itself, I need to remove A. So when I remove A and I bring A over to the right, A comes across the right as A inverse, which must be placed in front of B. Reason, because I'm pre means before. I'm pre-multiplying A by X. So when I bring A over as A inverse, I have to pre-multiply, meaning I have to put A inverse in front of B. So I'm going to put A inverse in front of B and multiply. We get unknowns, X and Y. So X, which is represented by XY, is equal to A inverse, which is that. what we did previously, right? We just show that. That's negative 4 over 7, 5 over 7, 3 over 7, negative 2 over 7 times B. Remember this is matrix B here, right? 16. Let's just test our knowledge of multiplying matrices. This here is a 2 by 2. That's a 2 by 1. The two and the numbers are the same. You expect your end result to be a 1. 2 by 1 matrix. How you multiply matrices? You take the rows of the first. By the only column. So let's multiply. First row by my only column. This will be negative 4 over 7 by 6. Negative 4 over 7 times 6 plus 5 over 7 by 8. Then second row by my only column. 3 over 7 by 6 plus negative 2 over 7 by 8. That will simplify to negative 4 over 7 by 6 is negative 24 over 7 plus 5 over 7 by 8 is 40 over 7 and 3 over 7 by 6 is 18 over 7 plus negative 2 over 7 by 8 is negative 16 over 7. So we simplify that. When the denominators are the same, we can keep the denominators and work out what's in the numerator. Negative 24 plus 20 will give us positive 16 over 7. A plus by a minus is a minus. 18 over 7 minus 16 over 7. The denominators are the same. So let's work on the numerator. 18 minus 16 over 2 over 7. So therefore we have found x and we have found y. Alright, remember your x is your xy and we root it out to get x as 16 over 7 and y as 2 over 7. Alright, so this will bring us to the end of this exercise. I hope that you were clear what we did on matrices. Look at the video again to make sure that we have clarity on what we've covered today on matrices. And of course, stay focused, stay committed, stay dedicated to the task. Right? Remember, excellence is equal to success plus commitment. So once you commit yourself and dedicate yourself to the task, you are going to be successful. Alright? So, see you in the next episode. Have a great one, everybody. Take care.